Yes, Kenneth.
Yes, thank you. Let's see if this has the same problem as Patrick. It worked when I sat there. It works here. Okay, I will talk about a new data type in Erlang called maps, or map. And why should we introduce that then? It's because other languages have it. Seems convenient in those languages. And it can be in Erlang as well, and it could even be better perhaps, because you can use the pattern matching mechanism as well. It could be an easy-to-use alternative to records, dicts, GB trees, ETS tables, and prop lists. It can complement records and make records unnecessary in the future, I think. At least in many places. There's two ways to approach this with maps. You can have the left side here with you can have it as a replacement or alternative to dict, GB trees, prop lists. And in that case, you have probably a map with many keys, but you don't have many instances with exactly the same set of keys. The other approach is that you have maps instead of records. And you might have seen a proposal from Richard O'Keefe called frames. And maps can indeed be seen as a subset. Frames can be seen as a subset of what maps can do. In that case, you might, if you use them as you use records, you will have probably many instances with the same set of keys. And maybe the keys are just atoms. In the general case, you can have any term as key. We try to combine this in the same syntax and semantics. So we have certain goals for this. We should provide a set of mappings then from key values. It should be easy to construct, access, and update. It should be a first-class data type like tuples, lists, atoms, so you can have guards testing them. The Erlang VM knows about them. You can do pattern matching on them. And it should be a defined order of the key value mappings. So it should not matter in how you create the map. If you create a map with one key first, and in another place you create the same set of keys, but in another order, they should come out to be the same order of the keys. And if you print them, they should look the same. And you should have no compile time dependency. You should not need to use include files declaring maps. And as I said, the parsing and the printing should go hand in hand so that you can print it and parse what you have printed, and if it's creating in a different order, it should print the same. So here's the syntax. First thing there is how to create the map. A new key with a value v there. And of course you can also create with several keys at once, several key value mappings at one time, and you can create an empty map. And you have some examples down there. And for example, this last, there you have a compound term as a key. It's the tuple A, comma B. It's an expression that's evaluated, and that will be the key. You can update, as you see, the syntax is similar to what you have in records, but you don't need to mention a record name. You can update the map M in the first example here with a new or existing key value mapping. The second example here with another operator, colon equals. We distinguish between adding possibly a new key or updating the value of a already existing key. And I think this updating an existing key goes together with when you want to use it as a replacement for a record. For example, in that case, you would detect if you have misspelled the name of the key. And I suppose also dialyzer might be able to take advantage of such differences in the operators. When we come to, we haven't discussed how to express these type specifications yet. And we have some examples here with updates. Last one is then updating an existing key with a new value. Pattern matching should work, of course, maps. This example shows then that you assume in the first handed call there that the third parameter is a map. It's any map, and you bind that to the variable s. And later on, you return this s, and you update the state key with the value start. So this shows how you can use maps for handling the state of a process, where in many cases today you use records. Maybe that's a corner case that we haven't. I have no good. I mean, this looks like an empty map, but it means here it's a map with any keys. Is Björn Egil here? No, can help me? I have to answer that later. Yes, you have guards with a map size, for example, but maybe that's inconvenient. I'll come to the guards later. And in a second example here, we match for actually a map which is supposed to have a key state with the value start. And then we update the state field to the key to changed. Continued about pattern matching here. The plan is here that it should be possible to bind a variable in the matching and then in the same matching as you use it. So in this case, the I is first bound here to the first element in the list, and then that value is used as the key in the map. And you get the value in bound here to the variable C, and then you can update it. And here we use this update existing key. Could have used the other one as well, and maybe it doesn't matter in this case, but potentially it could be more efficient like this when we know that the key exists. Yes. So this is an interesting kind of pattern matching that can be used. Okay, here's another example of pattern matching where you might have replaced a record use with a map instead. This file read file info, for example, it returns a record today, and it requires the user to include the record definition. If you use the map in a case like this, you would not require any include files. We also have single value access. So you can, with this curly brackets and the key name, you can access just that key and it will be returned as the value. And by this you can achieve some access to nested fields down in a hierarchy of maps. But the update of, I showed this also in Erlang Factory in San Francisco, and then I showed some example of convenient update, nested update, which actually was wrong. So I have corrected it here, and it's not so convenient anymore. So this is an area where we have to think more how to, if possible, find a really convenient way of updating deep down, just the value deep down in a structure. Map comprehensions is also available. In this case, it is you can have a map as a generator in the comprehensions we already have, and we can have a new type of comprehension which is building a new map from whatever generator you had from the beginning. And type specifications. This is an area where we haven't discussed with the dialyzer guys yet. That remains to be done. But it could look like this, that you can declare a thing as a map. You can say what keys you must have there and what types they should have. You can actually have the literals for the keys, for example, if the keys are atoms, or you can have the types suggested here, the type of the key and the type of the value. An important thing here is that maps are seen as ordered. So they are the keys in and values inside the map, they are sorted first after the size of the, if you have several maps, and I should sort them, which maps comes before the other one. And first the size that matters, and then it's the keys they contain, as if there was tuples of key value pairs in a list. It will sort the same as that. And of course, the actual data type map have a order among all data types as well. It's sorted, after tuple in the order of data types. Because this is a built-in data type known by the Erlang VM, then you can also have guard diffs that test if you have a map, and you can test for the size of the map, and you can use them in guards. And they belong then by tradition as all guard diffs to the Erlang module. In addition to that, we also have we'll have a maps module. Could always be discussed if it should have the name map or maps. Now we are mimicking lists right now, plural. And you can convert from a list to a list and from a list, of course. And the result here will look like a property list. You have more functions. You can create a map, but you can do that with syntax as well. You can test if a key is present in a map. You can get a certain key, but you can do that with syntax as well. You can put a value into a map. You can search for a key. You can delete keys. You can't do that with syntax. One key or many keys at the same time. And you can get just the keys, for example, and you can get just the values from a map. Or you can fold left or right over a map. And you can map over a map, as you can with list, and you can merge two maps as well. The internal representation here is, the plan is that we should have two different representations which is changed automatically. The user is not deciding this, it's into the VM to decide this. And if the map is, for example, below a certain number of keys, and it might also be that the keys are immediate values, then it can be represented like this, where the key, the green box here is the list of keys. And the idea with that is that it should be compact in memory, so you can reuse this key description when you have many instances of exactly the same type. And then you have the values in another separate area. By this you can get efficient storage, and you can get efficient lookup. Because there are, the maximum number of keys here might be around 32, 64. In that case, you have the option to do a quick, actually, search there to find something. And that's the typical for records today, to have not having more fields than that. When it grows in number of keys, there will be a tree representation instead. To have the order there from the beginning, we cannot create the order by sorting whenever the order is needed. So you keep the order. This is maybe not exactly this type of tree. It could be a more advanced tree structure, but you get the idea that it's a tree structure. And in this case, you cannot share the keys between two instances of maps, even if they should happen to have exactly the same keys. And of course, we have to find a new external representation, a new tag, and some internal structure of that one, which is not completely decided yet. And the use cases again for maps then. For example, you can use them when you build an XML parser to have the representation of what you parse instead of records as today. You can have it convenient for a JSON mapping. You can have it also for ASN.1 mappings. It's similar to XML, I think. You can replace many uses of property lists. You can use it in APIs instead of records to avoid include files. And you can use them for holding state of a process, for example, and by that you can achieve a better ways of doing upgrade. Records are a bit limited in that area. Here are some examples of JSON mapping. First, you see how it's mapped to Erlang terms in Mocky JSON today, and there are other similar mappings. You could map it to the map data type as below here. It's very, you see that the JSON and the map structure goes hand in hand there. And here's a bigger example of how you could view the JSON data as a map, and it looks almost identical. Here is more JSON examples. Where you can find the value ID in the first one. And in the second one, you can also find it with single value access. This is not what you want to see. You can, as I said before, use it in APIs. Of course, we don't plan to change this file, read file info in an incompatible way, but you could maybe introduce another function using a map as a return value instead. Process info is another example. It returns kind of a property list today. Of course, there are open questions. I mentioned this about the details about type specification and what dialyzer can do about maps. We have nested updates. We have, to be more exact, about external representation and how to be compatible with older nodes when we introduce this one. What should happen when we create the map in an R17 Erlang VM and try to send something to an R16 node? Should it crash? Should it be something that the R16 node can understand in some way? Summary. Maps are ordered. You can have any term as a key. You can have pattern matching, map comprehensions. We still have open questions, and your feedback is welcome. You can see a more detailed description in this link as an EEP, Erlang Enhancement Proposal. This is just a summary. There's more details in that one. And I think what we have described there and what I've said here is not written in stone. You can still convince us to improve or change something. We are working with this now, and the plan is to have maps in the R17 release, which is planned to come first quarter next year. And we will probably be able to release some prototypes about this that you can test in the later this year. Yes, that's all for me. Now questions? Yes?
Are the maps converted back when they shrink? Memory. You convert them when they grow, but you convert them back.
It could very well be so, but we haven't come that far in the implementation yet. So, I mean,
Because then I'm thinking if you have a map that's on the border, so it grows and then shrinks and grows and shrinks, so you do a lot of conversion. That would be a problem.
but maybe it also could be that it should not shrink, because if it has been above the border, it's probably not the type of map that have a stable set of keys, which is maybe the case we want to catch with the first representation. Okay. We take you first.
Performance, do you have any indication how it compares with record? Performance-wise?
Repeat the question. Cannot hear at all.
Okay, I can repeat. The question is how could this compare to records in performance-wise? And I can say that both these representation of maps will be less efficient than records, but the smaller representation with the shared keys can probably come close to record performance in most cases. Okay, we have you down there.
I have the mic here. If there is only one map in the Erlang virtual machine that has lots of keys, that will change the internal representation for all the maps then. Is that the case?
No. The representation is individual per map. If we choose the one or the other, just like it is for today, we have, for example, binaries. they are represented one way if they are below 64 bytes, and another way if they are above 64 bytes. You had a question there?
So why do you feel that the maps need to be ordered? Why do you put such a restriction on the data type?
Because it goes in line with all the other data types in Erlang, and it would be kind of, we have discussed this a lot, and the original idea was that it was not to be ordered, but then we came to the conclusion that it is better to have them ordered. And for example, this, that if you print them, send them to external media or something, that they look the same, and if you compare them, they look the same, and you should not require to sort them before sending them to external media. Before comparing, that would be very inconvenient. So then you have the ordered representation all the time. No, in this you don't have any. It will be the sort order depending on the key values.
I mean, I was more thinking what you could do if you would have a sort of hash map where you don't have a defined order, you can always sort it after orders. I mean, you would always sort of make it into a list and do a list sort on it before you send it. If you would like to sort it in a specific way, than always imposing the sorting, since it's always a cost of having the list sorted, having the map sorted. I was just
I mean, it's not a very big cost to have the maps sorted all the time if you use the tree representation or the other representation, but of course this rules out the hash representation that we could have used.
So that means if you parse a JSON document and then print it afterwards, you will have changed the order of the document of the keys and values. It will not be the original.
That would be a point, yes. If you take JSON data and convert it to an Erlang map structure and then print that one, it could look that you get the keys in a different order from the JSON.
Perhaps. I can never remember this actually, but
that's the point.
The order is important in XML documents.
But it depends on how you choose the mapping, of course.
It's, at least I can never remember whether or not in JSON documents you have to preserve the key order, or if the key order is actually can be written as you like, and I always get it wrong. But there's something there with JSON documents whether or not you have to preserve order or not, and I can never remember what is the right thing. So it might not be a problem there. For XML documents, you definitely need to preserve the order, but then it's not a hash map; it's a list in that case, I'd say.
But I mean,
so there's a different representation.
I recommend if you have objections of what I told you today, read this EEP and come with good reasons why we have chosen the wrong direction. Still time to adjust it if you have really good reasons. Okay, no more questions, I think.
There's one more.
One more.
Will you be able to use this in ETS tables or amnesia? So you either enter a map instead of a record or a tuple and can return it? Have you thought of an implementation for that?
We have no current plans to change that, but it could, of course, be a way of extending, for example, Amnesia, using maps as the record type. But from the beginning now, we have thought that map is just another data type you can have. It has no special meaning for ETS and Amnesia. Okay. Thank you.